GPT 4.1 is here, and it's absolutely wild. Faster than 4.0, cheaper, smarter, and completely API only. In this video, I'll break down what's new, compare it to Claude and GPT 4.0, and test all three models in real-world coding scenarios. Let's see why this model matters for devs. So what even is GPT 4.1? It's OpenAI's new flagship model. But this time, it's only available through the API. No ChatGPT interface, just dev tools. And there's a reason for that. This model is made for developers, and especially for code. But that's not all. This release introduces two brand new siblings, GPT 4.1 Mini and GPT 4.1 Nano. And these two models, especially Nano, are game changers. GPT 4.1 is already cheaper than GPT 4.0, but Mini is only 42 cents per million tokens. And Nano just 12 cents. That's OpenAI's fastest and cheapest model ever. And it still beats GPT 4.0 Mini on coding benchmarks. In fact, 4.1 Mini matches or exceeds GPT 4.0 on most intelligence evals while cutting latency in half. Nano is perfect for high-volume use cases. It's blazing fast with a 1 million token context window. Now I know what you're thinking. They are cheaper and faster, but are they actually smarter? Let's check the benchmarks. 4.1 completes 54.6% of real-world software engineering tasks. That's a massive jump from GPT 4.0's 33.2%. In a moment, we'll see what difference this makes as we give 4.0 and 4.1 exactly the same prompt. Let's look at how the model family breaks down. You've got 4.1 full for maximum reasoning and agentic behavior. Then 4.1 mini, your go-to for balanced speed and intelligence. And finally 4.1 nano, your default when latency and cost are the priority. So how do you actually use it? Right now, these models are only available via the OpenAI API, and they're fully integrated inside tools like Cursor. Just head to Settings, Models, and enable GPT 4.1. In the next section, we'll spin up a new React project and build a live flashcard app using 4.1. We'll preload Hindi vocabulary, add card flipping, dynamic search, and review stats, all with one-shot prompts. Then we'll compare that output to Claude 3.7 and GPT 4.0 to see which model performs best. Before the challenge, let's see how to use the new models in Cursor and from Python. We start at the OpenAI playground. I'll click here to open it up. We see the default model selected is GPT 4.1. I'll start by asking it to tell a joke. Let's send that. And we get a response back. Why do programmers prefer dark mode? Because light attracts bugs. Now let's try changing the model. I'll click the drop down here. I'm going to select GPT 4.0 Mini. Now let's give it a different task. I'll type, write a blog article about large language models. We can see the model generating the blog post. Okay, now let's see the code for this interaction. I'll click the code button. This pop-up shows us the Python code needed to replicate this chat. We can see here it uses the 4.0 Mini model we selected. Now let's switch over to the Cursor editor. I'll open the settings first. Let's navigate to the model section. We can see a list of models available within Cursor. We see that 4.1 is available. Let's close the settings. I'll create a new file in our project folder. Let's name it app.py. I'll paste the code we copied earlier from the OpenAI playground. Now let's use Cursor's chat feature. I'll select the model for the AI agent first. We'll use GPT 4.1 for this task. I'll ask the agent to remove obsolete code. The agent suggests removing the parts we don't need for a simple API call. That's still a bit much. Let's tell Cursor too much. Please a simple API call and output the result. Okay, it's generating a much simpler script now, just focusing on the core API call. I'll accept this version. Now let's specify the model. I'll type use GPT 4.1. It's applying the change. We'll accept this update. It seems to have used for preview, which is not exactly what we have aimed for, but we can easily fix this later. Let's open the terminal. Let's try running the script with python app.py. We get an error. It says the API key is missing, which makes sense. Let's go back to the OpenAI platform. I need to create a new key. I'll name it GPT-4 test. Now I'll copy the generated key. I need to export this key as an environment variable. Before running again, let's set up a virtual environment. This creates an isolated workspace with its own dependencies and interpreter, allowing you to manage project-specific packages without affecting the global Python installation. And we need to install the OpenAI library. Let's clear the terminal. Let's run python app.py again. We got the joke output. Why don't skeletons fight each other? They don't have the guts. Now I'll quickly modify the code to use GPT-4.0-mini instead. Let's run it again. And we get a different joke this time using the mini model. Okay, let's make the script interactive. We use the input function to set the content of the message dynamically. Let's run the interactive script. It asks for a prompt. I'll enter, write a blog article about LLMs with 500 words. We can see the blog post being generated and printed to the terminal. Let's quickly demonstrate changing the model one more time. I'll change the model string to 4.1 nano. Let's run the script again. I'll enter the prompt. Write a 500-word article about LLMs. And we see the output generated by the nano model. Time for our model comparison. Let's start with GPT-4.0. On the left side, you can see a stopwatch so we can time the task. In Cursor, GPT-4.0 is selected as the agent. I'm pasting in a detailed prompt to build a flashcard web application. Let's start the generation and the timer. GPT-4.0 is planning and building the React application. It's creating files and installing packages. After about 3 minutes, GPT-4.0 says it has finished the task, but when I run the npm start command, it doesn't work. Let's copy the error message into the Cursor chat window. I'll not give any hints or help the model in any way. GPT-4.0 identifies the missing dependency and installs React Router DOM. After about 3 minutes and 20 seconds, we can open the running flashcard application. It's not exactly a masterpiece. It looks very basic. It's not surprising that 4.0 isn't the best option when it comes to building software. Now, let's try the same task with Claude 3.7 Sonnet. I'll select Sonnet as the agent model in Cursor. We'll use the exact same flashcard application prompt. Sonnet is now creating the application. It seems to be taking a simpler approach, creating an index.html and an app.js file directly. It's finished generating the files. Let's start a simple Python HTTP server. Here's the application generated by Sonnet. What a huge difference. It's like comparing the result of an HTML beginner and a senior front-end developer. Sonnet built a functional, clean-looking version in about 2 minutes. Let's reset the timer one last time. Finally, let's test 4.1. I'll select GPT 4.1 as the agent model. Again, we use the same flashcard prompt. Let's start the timer and the generation. GPT 4.1 is starting the process. It looks like it's using Create React App. All right, after about 4 minutes, Cursor tells us we can start the application using npm start. It encountered dependency issues. Let's copy the error and paste it. 4.1 identifies the missing module and suggests installing Web Vitals. The app is running. Let's check it out. Let's flip the first card, moving to the next card. The design is much better than the result produced by 4.0. I'd say on the same level as Sonnet 3.7. We see the stats component. Okay, but there's no way for me to indicate that I know the answer. Let's sum it up. Sonnet 3.7 takes the crown. Fastest and by far the best result. 4.1 is slower but solid. 4.0 finishes faster than 4.1, but its solution just wasn't usable. There's a clear performance gap between the good old 4.0 and the new 4.1. A big step forward for OpenAI. But for now, Sonnet still leads the pack, at least in my tests.